Okay, I think we're live here on YouTube.
Hello, everybody. I think I'm going to do a little brief introduction. Again, we started about 6:30 and discovered we weren't totally connected with everybody.
Still not live.
Still not live. Okay.
Okay, Rick, I have you spotlighted. Is that what you want?
I think I got a little notice that we are live now, I think. Let me just confirm with everybody. We're
Yes.
on.
Hey, Rick, I have.
That's fine. I think I just lost you, though. All right, everybody. Hey, I just want to sort of like welcome everybody to International Observe the Moon Night. We were having just some technical difficulties for the first 4 or 5 minutes, so I did a little introduction, but I'm going to do it again. My name is Rick Alling. I'm at the School of Earth and Space Exploration at Arizona State University. We have our main campus is in Tempe. I'm actually operating out of my backyard right now because I have some camera views and some projections from the moon that I'm going to show people a little later tonight. We have lots of activity tonight, so we're going to go move around from place to place. We're going to visit some people and do some crowd talking, not only on the ASU campus, but also in Fountain Hills, Arizona. We also have a remote setup, an astronomy club. It's way up in North Phoenix in a park. We're going to try to link with them as well and see some moon shots from them. But tonight is all about the moon. And tonight is all about observing the moon. This is not necessarily, I mean, we'll dabble in a little science. We're going to tell people some things you didn't know about the moon before. But most of all, this is about culture and about us viewing the moon and about us standing in our backyard, looking up and seeing what we see. We'll give you some insight into why the moon does the things it does. We'll talk a little bit about the eclipse last week, and all of that wrapped up into a 90-minute program with lots of moving parts and pieces. So I'm going to introduce two characters that you'll need to know. Kim Baptista is our webmaster, and she'll step in every once in a while if we get off track. And Meg Hufford is working in the background, kind of keeping the backstage handy and keeping everybody ready to go live when it's time to. Also, we have an ex-student, Alex Blanche, is with us, and for those of you that have seen our virtual programming in the past, you'll recognize him. Unfortunately, he graduated, but fortunately, he has tonight off, and he's joining us again, so that's really super cool for us. All right, without any further ado, we're now just a little bit behind because we got started a little bit late. We want to move to the Lunar Reconnaissance Orbiter camera. This is a facility at the ASU campus, and they have some telescopes set up. They're going to have some crowd mingling about, but we're also going to get a tour of that facility and what they do in lunar research and why that's important right now. So I'm going to kind of just let's switch over. Sam Campbell, one of our students, is running a camera, and the team there that's going to give us a tour will introduce themselves, and here we go. There you go. I saw you for a second.
Hey, so we're at the LROC Science Operations Center, where we operate 2 different camera systems in orbiting the moon: the Lunar Reconnaissance Orbiter camera and Shadow Cam. Our facility here is open weekdays from 8 to 3, so anyone can come by and see more. So we can see as we move down the hallway here, we've got all sorts of great moon images. All of these were taken with our cameras that have been orbiting the moon. And we can move into our gallery here. So here in our gallery, we do lots of tours with students and other community groups. But this is where we actually operate the 2 instruments that we command here, LROC and Shadow Cam. If you're come here during the weekday, you'll see our ops filling the room here, making commands. On the back wall, we've got live telemetry from our spacecraft, make sure the health of the camera is okay. And then we have a big tile wall up there where you can see current imagery of the moon. Those would be images that have been taken typically within the past 2 to 4 days. And we show images both from ShadowCam and LROC there. So LROC is the camera system that we've been operating the longest, and we do have a couple of models here available. So LROC we launched in June 2009. So we've been in orbit for just over 14 years. And so this little guy right here, this is our wide angle camera. So this camera, it'll fit in the palm of your hand, but it has 5 visual bands and 2 ultraviolet. And in its primary mission orbit, we had a resolution of 100 meters per pixel. So we can actually get global coverage every 28 days with this camera. The repeat coverage that we get over 14 years allows us to build up 3D models and photometric models and learn a lot more about the surface of the moon and the reflectance of the materials. To the right of this camera is a model of the LROC NAC. And so you can see kind of the black tube here. So that is the LROC NAC. So in our primary mission orbit, that had a resolution of 50 centimeters per pixel. And with that one, after 14 years, we have not quite gotten 100% coverage of the moon yet, but we're getting there. We're at like 98 or 99%, but it's at all sorts of different lighting conditions. So you can't put it together into one continuous map. But the narrow angle camera at its primary mission orbit had a resolution of 50 centimeters per pixel. And so these images that it takes, there's actually a pair of them that overlap just a tiny bit so we can get double the width. But we can get about 5 kilometers by about 50 kilometers in a swath with these. And it's a monochrome instrument. They actually call it panchromatic. It takes a large amount of light, but it outputs in black and white. And so with this camera, we can, of course, take images. We can make mosaics. All of the missions that are currently going to the moon, we've got Artemis, we've got all the NASA commercial missions, other countries that are going to the moon. The map data that they're using is coming from this camera. The new camera that we have just got into orbit this past December. So we've been operating for almost a year, not quite yet. And so we've got a model of that up on the table. You'll see it looks an awful lot like the NAC. And that's for good reason. We get all that heritage of the telescope for the NAC and the electronics for the NAC. But we did make some modifications. The one area that we can't see with the LROC NAC are the permanently shadowed regions. And so the moon only tilts about 1.5 degrees on its axis, unlike the Earth, which tilts about 23.5 degrees, and that's how we get our dramatic summers and winters. The moon only tilts that 1.5 degrees. So any craters near the poles on the moon never see any direct sunlight. And because they never get direct sunlight, with our narrow angle camera on the LROC, we've not really been able to image in those. But with ShadowCam, it's 200 times more sensitive. So we're on a spacecraft. It's actually Korea's first lunar spacecraft. It's the first spacecraft South Korea sent outside of Earth's orbit. And so the spacecraft, we're 100 kilometers above the surface, and we're traveling at 1.6 kilometers a second. And so under those conditions, taking pictures of something that has no direct illumination, it's really challenging. But that camera is 200 times more sensitive. And so we're actually able to start getting some of those images. In fact, the image on the back wall right now is one of the ShadowCam images that's recently come down from the spacecraft. And so this is going to help us tell the story. You know, a lot of exploration right now is water ice and other volatiles that may be stored at the lunar poles. And it's in these permanently shadowed regions where they're likely to be stored. There's been lots of other instruments that tell pieces of the story, but this image data will help tie all of those pieces together. And then if you are able to come down and visit us, you can also see in our gallery in the far corner here, we have a lunar rock. It's a sample that was collected by Commander Dave Scott on the Apollo 15 mission. The original sample was about the size of a football. It weighed about 22 pounds. And of course, it got cut up for study. And so we're fortunate enough that Johnson Space Center has put this on loan to ASU. So we do have a moon rock here at ASU where you can come look at it. You know, it's from the Mare areas on the moon. Those are those darker areas you see where it's ancient basins filled with volcanic activity. So this rock is really similar to like the lava rocks you find in Hawaii. But of course, it hasn't turned red like you're used to with lava rocks because it hasn't been exposed to atmospheric water. So hopefully people get a chance to come down and see our facility. We've got lots more signs. We've got a lunar history walk. You can always see what's going on. There's always new images to see, and we're happy to give people tours.
Nick, thank you so much for your help and your tour. I think that's great. We're going to be visiting back with you a little bit later tonight. Here, let me turn my camera on so you guys can see me. We're going to be back with you a little bit later tonight on a couple of segments. And next time we see you, I think we want to see some people using telescopes out in front. We'll see if there's any students wandering by that we can chat with about Observe the Moon Night. But it's been a very special relationship from our end over at the School of Earth and Space Exploration and the work that we do, and the Lunar Reconnaissance Orbiter camera team, because they are the go-to place for all kinds of assets and resources about lunar imagery, lunar details, all of that kind of stuff comes from them. And we're proud to have them on the ASU campus. We're proud to have them as part of our Observe the Moon Night. Thank you, Nick. And I also want to hear, I think you were out launching rockets today in the desert. I want to hear about that before the night's over as well. So the next thing we're going to kind of move to is a kind of an old friend of ours. Kevin O'Donnell is I call him sort of an amateur astrophotographer, but he takes it way beyond just the amateur level. This has been a passion for him. He's been doing astrophotography for many, many years. And his work is always dazzling. People always appreciate it. And so we called him and asked him maybe if he could kind of give us some insight into taking images of the moon and how he does it and what kinds of those things. So let me invite Kevin to the table, and we'll see if we can kind of get a point started, and we'll see where we go from there. Thank you.
Thanks, Rick.
Hi, Kevin.
Hi, how are you?
Good. We haven't seen you for a little while. We stopped doing our regular virtual programming, and anyway, now fewer and far between. But yeah, you're missed, but you're not forgotten. So let's see what you got for us.
Yeah, I wanted to focus mostly on the moon tonight. As Rick said, I'm an astrophotographer. I do appreciate everyone being on the call, and it's really great that people took the time to come and see this. I'm based in the North Phoenix area, about an hour away from the darker skies in Sedona and Wickenburg. A little further away, pictured here, is Flagstaff. And I'm also on Instagram, where I share most of my photos. So I've been a photographer professionally and personally for about a decade, and began to specialize in astrophotography about 6 years ago. Like Rick was saying, I take night photos of the Milky Way and stars. This is sort of my best of collection. So it's got planets and comets and the International Space Station and SpaceX. A lot of people have been talking about how you can see the launches over out of California, all the way 500 miles away from Phoenix. There's a zodiacal light in pictured here, and air glow, eclipses. And then I take long exposures as well as nebulae and galaxies. But we're talking about the moon tonight, so that's our focus, and I want to show some photos and what you can be doing with that. My telescope isn't really a telescope. I don't actually own a traditional refractor or reflector telescope, but instead use like mirrorless and DSLR cameras paired with a variety of lenses mounted on star trackers to shoot the night sky. So astrophotographers have a love-hate relationship with the moon. On one hand, it lights up the foreground at night, but usually too much, actually. This short 8-second exposure here of the duck on the rock over at the Grand Canyon was shot at 11 p.m. actually, which was a nearly full moon that night. And it just shows how bright the moon can be. It looks like a sunrise shot instead, except for the stars at the top. So, why don't we take pictures with the moon always? It's a great question. People wonder what it can do. So I tried to find some photos where the moon was up and then it was set. And so back in January of this year, I took photos of Comet ZTF up in the dark skies of Sedona. So at 10:20 p.m., there was a 20% moon that night. Before it set, you can see kind of a grayish sort of tint to the background, and it's hard to sort of make out the comet. But just 2 hours later, the contrast was much greater. The sky was darker, and this is the exact same processing as this previous image. I haven't changed anything. And that's how much the moon can actually cause light pollution for astrophotographers. So another question people ask is, why can't you see any stars in your moon photos? And the reason is the moon is so bright, you have to take fast exposures. So this is a half a second, which may seem kind of fast, but it's actually not as fast as cameras can be and not as long as exposures as we can take. And I've pointed out the only star that's sort of visible in the shot here. And then just so I'd have the comparison, I took about an 8-second exposure. So it's the same location, same framing, everything. But now you can see some stars, and you can also see how much the moon is blown out. One of my friends said it looked like a tennis ball. So keep that in mind if you're taking pictures. So what do you do when the moon's up? If you're going to focus on the moon, and we have to, because half of the month the moon is going to be either up in the sky or setting or coming up at some point, or a full moon out all night. So here are some options. Moon rises are great. This is a setup that I did over in Carefree, pointed at 4 peaks, and you can barely see it here in the LCD screen. This is the end of my sort of production for that afternoon or evening. And this was the actual shot. So a lot of times you'll see a giant moon in a photo and wonder how it was taken. And now you saw that. It's a 600mm lens, and it zoomed in, and it makes the moon look huge in the shot. Another fun thing you can do is conjunctions. Because things will pass in front of the moon, it's great to find objects to frame in that way. In this case, what I did was I found the flag, the American flag, up on the top of Daisy Mountain. And you can see it in my LCD screen down here in the lower left corner. And I'm pointing to where that's actually pointed to up on top of the mountain. So that's 2 miles away. And here's the top of that mountain, because I've hiked up to the top of Daisy Mountain. And so the conjunction is this shot here. So you can see the American flag over here in front of the moon. And it's always best to try to get those conjunctions right as the moon is coming up, because once it gets super bright and high in the sky, they're tougher to achieve. So another conjunction was this very patient owl that worked with me. So he flew over to the top of a saguaro, and I framed him in front of the moon, and he was only there momentarily, as the image on the right illustrates. You can also take trees or saguaros in this case. A good way to do this is just kind of drive around neighborhoods as the moon is coming up, and you might have to move 3 or 4 spots, but if you find some mountain up here, you can jump out of your car and take some quick pictures like I do. Clouds are always going to be a problem with astrophotography, so you just kind of have to embrace them. This was a night where I looked up, it was a full moon, and I could actually see that blue and that orange in the sky. And some of you might have seen this stuff before. You might have seen moon bows, a big round circle around the moon. So I just try to embrace whatever's available. Earthshine is another phenomenon. It's a great time of the month to take the moon. It's usually a couple of days after a new moon, and you'll see just this sliver of a moon up in the sky, but you can actually see the rest of the moon. And that's because the sun is reflecting off our bright planet. So it's actually Earth's reflective light that is casting back onto the moon and illuminating the otherwise darker side that you couldn't see. Here's another example of that Earthshine, as they call it. This is in Flagstaff near some pine trees. It only occurs, though, again, or is visible a couple of days after the new moon, because then it gets too high in the sky and you can't see the darker section of the moon anymore. Something that's also very popular is double exposures. You see a lot of these online now. So what people do, as I did here, is you take a long exposure first so you can get some stars in the glow. Then you take a very short exposure again and you overlap the two. And so you get this unique experience that you can't really see yourself. Sometimes, though, it's just easier to take the glow of the moon. So this is just the moon coming through some leaves, and it looks like a bright light over there. Another example of that is from that same spot I was talking about at Daisy Mountain. To me, it almost looks like a giant ball that's about to roll off of the hill. So glow is also something you can do with the moon. If you just want to do something fun, I encourage you to try something like this. This is an invert. I took a picture of the moon and I just inverted the photo and placed it over some stars from earlier that night. To me, I call it the coconut moon because it has such a completely different look than you're used to. Something else that's fun are these transits. So what I have here is I have the International Space Station flying over the moon. What happens is that it's tough to line this up. There are sites out there that can show the location where you can visualize this, but it's 1 second. There's only 1 second of data happening here. Now, I've shown the camera view and then I've shown the actual 30 frames that were captured, but don't blink because it will be over quickly. Another thing that you can look for are occultations. These are scheduled and you can look online and see where they occur. In this case, it's Mars. So go back. So it's Mars actually going behind the moon. Now this footage is actually sped up about 2000%. It moved much more slowly than that, but just for the purposes of this webinar, I've sped it up. It takes about an hour to go completely behind the moon and then reemerge on the other side. But that's something else that you can look forward to. So I'll stop there for now. I'm going to talk about eclipses in a bit, but I want to throw it back to Rick.
Thanks, Kevin. Thank you so much. I always love seeing your stuff, and you're just so creative and clever, and you don't just sort of focus on just the traditional thing and do it over and over again. You really use light to the best advantage. You really you do an amazing job, and so it's always a pleasure to have you work with us. And what better way to sort of take in International Observe the Moon Night with kind of an interview with you and seeing how you're doing it.
Well, thanks so much, Ray.
Tell me, so is the moon your favorite target? Or do you just kind of like, is there all kinds of different things that you like to do?
Yeah, so as I said, I mean, astrophotographers have this love-hate relationship. But as I said, you know it's going to be up at least half the month. And unfortunately, the other half, you're going to have clouds. So if you're going to be an astrophotographer, you just have to be kind of flexible, because there's wind and there's storms and there's clouds and the moon and all those types of obstacles. But there's great things that can be done with the moon. And I'll talk a little bit about eclipses, and there's something to look forward to and put on your calendar for sure.
Excellent. Thank you very much. And you hang tight, because you're going to be back in our show, the middle segment of our program. We're kind of recapping the eclipse and the moon's role in the eclipse. And I know you have some stuff that you did last weekend. So I want to see it myself, and I want to show it to the audience. So thanks, Kevin. Thank you very, very much. So I'm going to ask or tell my team, and we're sort of getting caught up a little bit. I'm just going to show everybody just an image of the moon. And let me see if this will work here. I think you can see that. That's your moon. And this is actually a telescope shot from my backyard. So let me just kind of show you a little bit here. I can move it around a little bit. I can also, if I'm very, very careful, I can zoom in a little bit. I can't zoom out, but I can zoom in. And so what this is a live camera hooked up to my telescope. This isn't as really super cool and wonderful as you're about to see. I wanted to
turn it around.
somebody's online. So I wanted to introduce you to a friend of ours, somebody that's kind of helped us before in the past, yet another amateur astronomer, somebody part of the Phoenix Astronomical Society. And he is actually now with a group of people way up in North Phoenix. I think he said Joe Max and Carefree Highway. And let's see if we can get him on board. I'm going to turn my projection of the moon off, or my image of the moon off, and we'll turn his on, and we'll see where we go from there. Hey, Mark, are you on?
Yes, I am. Can you hear me?
Excellent, I can hear you. So let's see if we can get you on camera here. We're going to spotlight you.
I'm gonna. Well, okay. You're gonna get me first. Or want me to go to the
Well,
moon?
you could go to the moonshot if you want.
Okay.
I don't know if you saw. I just had one up there. I got a.
Yeah, I see that. Now, are you seeing what we're showing here now?
Yep, it looks really good to me.
Okay. All right. Good. So, like you said, I can do the same sort of thing you just did. I can zoom in a bit. So there's 40%. And, of course, it's a lot of fun to be looking along the crater, along the terminator of the moon. There's, 100%. And the controls are covering up my cursors. There we go.
Yeah, I know. So I'm going to actually stop you for a second, because you said an interesting word called terminator. I call it terminus.
Okay.
But I'll bet you most of our audience have no idea what that is. So we better kind of give a little primer. And so go ahead. Why don't you take it?
Sure. Okay. So when you look at the moon, when it's at first quarter, for example, like we're seeing it now, or a few days before and after, there's a bright side and a side you don't see. And the side that you see, of course, is illuminated by the sun. And you can imagine the sun's rays coming in this view from the right-hand side. And where the moon disappears into darkness, that's the terminus of the terminator. And that's where the light basically terminates. Essentially, it's the sunrise sunset point on the moon. That's where the sun is just barely visible or not visible. And that you can imagine it encircling the entire moon, so that if you look at it in 3 dimensions, the whole front side that we see here would be illuminated, and the part to the left would be in darkness. And as the moon moves into its gibbous phase, more and more of the side that's facing towards the Earth is illuminated, and the terminus of the terminator moves into kind of an arc shape until we finally end up with a full moon, and then the process goes backwards.
Excellent. And can you zoom in a little bit? Because I just wanted to show something. This is really good.
Sure.
if you are interested in this, and you don't have to have a really sophisticated telescope like Mark has here. You can have just a regular hobby telescope, or even a nice pair of binoculars. And what's happening, because the sunlight is glancing off the moon at an angle here, instead of full straight on when you see a full moon, the light and the glare reflecting back just doesn't give you a lot of detail. But now you can see those craters, especially down towards the bottom of the screen. You can actually see the shadow and the light on the half of the crater, and that just gives you a really, really good view of the detail of the mountains. Look just a little bit up towards the top of the screen. Between that round darkish circle is the Sea of Serenity, or Mare Serenitatis, and right next to it on the left side, you can see just a kind of a whole row of mountains. That is a little bit invisible to you when you're sort of looking at a full moon. So I sort of prefer, I don't know, Mark, if you agree, but I kind of prefer to basically do my moon investigations and get my telescope out when it's not full, but when it's in sort of partials. And then that terminator actually moves every single night. So you've got a whole new exciting sort of, part to see every single night, because it shifts and you can sort of really learn about the topography really well. Are you still there with us, Mark? Oh, we might have lost him. Oh, shoot. I'm going to go back to my view while we're trying to rescue Mark from the thing. So I think this also sort of illustrates that particular point. And a little bit later in the program, I'm trying to get us out into space. We're running a little bit behind, but get us out into space and just kind of talk about phases and how phases work.
I'm back.
Oh, you're back. Okay. And how the orbital elements
lost the connection here. Yeah.
Oh, that's all right. No, you're coming in loud and clear here. So basically, I was telling everybody how much I prefer to look at the moon when it is actually a partial moon, either sometimes just a crescent, a quarter, a gibbous, because you always have that shadow line is really enhances the topography of the moon. And I would guess you agree, right? Oh no, we sort of lost Mark again. So Mark is up at a place called Apache. Oh, there he goes. Apache Wash up in North Phoenix, and clearly we're having some trouble getting them. But we did have a nice for Mark. We did have a really good view from your telescope for a little bit. I really appreciate you checking in. And
is that not visible now?
Let's see.
I'm sharing my moon picture now.
Yeah. We see you now. Yep.
Okay.
Show the telescope.
Did you want to have a look at the setup I've got, Rick?
Yeah, please, if you can. If we've got enough.
We're going to turn the laptop around, and hopefully we can. Oh wait, I've got to stop this share.
Yeah, you have to stop the share for a second.
Okay, so put me on.
Kim, can you spotlight Mark on this one?
All right.
There we go. I can see it now. So this is a refractor telescope. Why are you using a refractor rather than a reflector?
160 FL, and it's super high contrast. It's absolutely an exquisite instrument, and it's really good for the moon, for planetary double stars, things like that. It's a 160 millimeter apochre mat.
Okay.
So that's the setup. And then I'm going with a ZWO MC Pro camera. I'm going from there directly into SharpCap on my laptop. And then from there, I go to a television so the people who are here at the park can have a look at what we're seeing here. I can put the moon back on if I can share again, if you'd like to see that.
Yeah, absolutely.
Okay, let me put the moon back on. And I'd like to introduce, it's dark here, but I've got Stu Brackney with me. He's the president of the Phoenix Astronomical Society. And I'll let him just say a few words about what we're doing up here tonight and about our club.
Excellent. Thank you.
Hi, guys.
Hi, Stu. How are you?
Well, I'm doing fine, and I have attended a lot of your events, and you have done so much for the Valley as well as statewide on astronomy, and that's what PAS is all about, the Phoenix Astronomical Society. We've been around since 1948. Started, guess what, at Phoenix College when it was the only community college in the Valley.
Yep, I
And
remember.
we've been around for quite a while. We've got a membership of about 125, maybe 130 now. And what we're doing here tonight is honoring this celebration of the moon. We have been coming out to Apache Wash ever since COVID has ended, and we're starting to like this as our good site. We have a website, pasaz.org. That's pasaz.org. People can go there and see all of our events for the whole year and know what we're doing, like coming out here tonight for other star parties. We have telescope workshops at Paradise Valley Community College. We have a lot of fun. We've got experts like this guy right here, Mark Johnson. He knows what he's doing, as you well know.
I
And
can say so.
then we have a lot of amateurs who are just getting into the fun of looking at the cosmos. And that's what astronomy is all about, enjoying what you see and learning more about it. And we appreciate the opportunity to participate in tonight's event with you. And I'll turn it back to you,
Hey,
Rick.
Stu, I have a couple questions for you, though. I just wanted to sort of suggest to people. Well, first, thank you for your comments. It's been great to have a good relationship with folks like you. You have the passion, right? And so that's really kind of fun to see. But I get calls all the time. It happens, right? It's like, what kind of telescope should I buy? Or, just kind of those questions. And invariably what I do is I say, look up your local community astronomy club and just get in touch with them, find out when they're going to be out and doing an event like you're doing tonight. And you guys are great. So if somebody is just sort of like, how do I get into this? What's an entry-level system? What should I do? They can actually go out and talk to you guys and sort of look through your scopes and get a sense of, what you need to make it work. And so that's a service you provide that people don't really know about. So if you call me, I'm going to send them to you because you guys
There you go.
practicing.
Rick, you're absolutely right, because on our website, when I mentioned to you that we have the whole year's events lined up, on those lists of events, we have workshops that we hold both out here at Apache Wash and in the classroom at Paradise Valley Community College. Number one, what to buy. Or if you bought a new telescope and it's been in the garage for a year or so, you don't know how to use it, let us know what that telescope is. We'll marry your telescope and you up with someone in our organization who can teach you how to use that telescope right out here at Apache Wash under the gorgeous sky of Arizona.
Excellent. Stu, how often are you out there? Is it
We're out here
once a month thing?
Well,
Or is it-
first of all, the classes are held here at least once a month for how to use your telescope. Same with the what to buy telescope at PVCC. That's once a month. We have our monthly lectures under the system that you're using right now. We have classroom speakers. By the way, Rick, many of our speakers are coming from your campus, by the way, and your program.
That's good.
And I really appreciate the knowledge and the expertise that they share with our membership. But when they come to lecture our members, we also send it out on a Zoom system, like you are doing tonight, to our members who can't make it to the classroom at PVCC, which is around 32nd Street and Union Hills. But back to your question, we do that every month, our lecture series. And then we have star parties. They happen at least once a month. So we're kind of a busy club now that COVID is over.
Yeah, I think that's great. And really, I just really appreciate Mark. And I, even as of about this afternoon, we weren't quite sure whether we're going to be able to make this link, but clearly it worked. And we've got a great image of your view and your ZWO camera and what you're seeing out there. So if this is about observing the moon, you can't get closer than this, right? So I appreciate what you guys are doing. And I really like that you joined our team here. What we might do, if you don't mind, Mark, is I might just try to reconnect with you just in the last 5 minutes, just about 5 minutes to 8, just to see how you're doing. And
Okay, yeah, if the technology gods support us, we'll be
if they
there.
support us, and if not, we'll say good night. And thank you very, very much for linking in. I think this is great. Have a great
right.
time out there. It's
Awesome.
actually it's a beautiful night. I'm sitting here. I'm in Central Phoenix, and I'm outside, and it's gorgeous. So
It is beautiful, beautiful dark sky up here.
Great night to be out looking at the moon for sure.
Yeah.
So thank you guys. Thanks very much. So next on our agenda, we have been actually working really closely over a couple of years with Fountain Hills, a community, a group in Fountain Hills, actually two groups. One kind of started a community astronomy kind of initiative, and they created for themselves a dark sky community in Fountain Hills. And then they've been doing events. I think we did our Observe the Moon Night from there either last year at this time or the year before that. And so we like each other. They've got a great program, they've got enthusiasm. They've got some events coming up and some things to talk about. So I'm going to try to get Vicki on the line here, and hopefully Vicki can join us and give us a little sort of like view of what's going on there. Vicki, do we have you? Are you on?
I'm here, Rick. I don't think my video is on. Can you hear me?
I can hear you fine, and I can't see you, but I can read your name.
Yeah, I think that my video has been disabled. So if someone wants to turn that back on.
Okay. So tell me, just while we're waiting for your video, tell me what you guys are doing. How many people are out there? And you started right at 7, so you haven't been out there. Your party hasn't been going on very long. Is there a lot of peoples?
We've got a small crowd, but people keep coming up, and we're going to be here till 9 o'clock tonight.
Okay.
So I'm expecting we're going to get a lot more people in here. We had Make a Difference Day out here earlier today, so we got a lot of tired people.
You're not a big enough community to do 2 big events in the same day.
Yeah.
So Vicki, I just brushed over the important work that you're doing, but can you just kind of give us a real quick overview of your plans and your center? And I think I read an announcement about 3 or 4 months ago that you have some sort of link with in a partnership and an agreement with the Smithsonian to help kind of support your work. So walk us through that a little bit, and what are you trying to accomplish, and how far away are you?
Yeah, we're pretty excited. So Fountain Hills is out on the eastern edge of the Phoenix metro area, small community out here, but we are the world's 17th international dark sky community, which is a really, really special designation since we're so close to a major metro area. We became designated in January of 2018, and we have done 4 dark sky festivals here in Fountain Hills since then. And the one that we had earlier this year, Rick, we had 3,000 people show up to this festival, which was phenomenal for our town. Yeah, and so we're really excited about what's going on here. We have a lot of support all over the community, doing a lot of education and awareness here. But the people who really helped with getting this dark sky designation was so interesting, because once we got it, Joe and Nancy Bill, they thought, I wonder what else we could do. So they got this great idea of, well, maybe we could build an observatory, or maybe we could build a planetarium. So what we're actually doing, Rick, is we are building the International Dark Sky Discovery Center here in Fountain Hills.
Okay, yeah, I heard of this. Good.
Yeah, it's going to be 22,000 square feet. It's right next to where we're set up here tonight. So we have the library, the museum, the community center, the community garden, and then this facility is going to go in here. And it's going to have both an observatory and a planetarium and a theater and an exhibit hall. We are really hoping to hit our fundraising goal and break ground the first quarter of this next year. So that's really exciting for our community.
That is really exciting. That is really amazing. And this is an asset for everybody in the Phoenix area, right? So,
yeah, the whole state, really, because Arizona is a very important state for astronomy. We have a lot of dark sky communities and parks. And so dark sky preservation is really important to the economy of Arizona. So we're really happy to be part of that.
Excellent. Well, I really sort of appreciate that. And so I think what we're going to do is we're going to kind of take a little break. We're going to try to come back and visit you a little bit later in the program also, if that's all right. And we'll let a little bit more crowd come in. So do you have some telescopes set up and stuff?
We do. I think we have 7 telescopes set up here. We also have the Fountain Hills Library, who has a table and featuring their telescope lending program here in Fountain Hills. We have a booth with Night Sky Tourist, and our Fountain Hills Dark Sky Association has a booth as well. So we've got a bunch of fun stuff happening here. We have some giveaways, And so we would love for more folks to come on down here tonight.
And so, okay, absolutely excellent. And so another community group and kind of rallying around Observe the Moon Night. And so I hope this is going to be an annual thing for you too, right? So
Yes. Well, you started it here. Thank you, Rick.
we're going to keep doing this every year we can. I think it's great. There's all kinds of new missions to the moon. Science on the moon has become way more important again. I think we heard a little bit of that from Nick Estes earlier this evening. There's new missions to the moon. There's all kinds of stuff going on. So we've got, so at least we should do it more than once a year, but at least once a year, we got to touch base. We got to get the community kind of rallied around this moon and what we're doing here. So well, Vicki, thank you, and say hi to all the folks out there. Is Scott there?
Scott is here. He's actually taking some images of the moon tonight.
Okay,
and then he's going to go home and process them and give those to our guests tonight as a digital copy.
Oh, I see. It's a good idea.
Yeah.
It's a good giveaway. Well, Vicki, thanks for touching base. And we've got another slot with you. We're going to try to get back to you a little bit later in the evening. And here's my goal for you is to see if you can find somebody, just a public. I just want to kind of talk to somebody, just the public that wanted to come out and sort of like get involved in the excitement and what they think of it. Okay.
Absolutely. We'll be ready for you.
Okay. Thank you, Vicki. Sounds good.
All right.
Good. So for my team, here's what I'm going to do. I'm going to skip the next little part of the program. I was going to show people some orbital elements. I think I can do that a little bit later, a little bit easier. And so I think if we tee up, I want to introduce a professor from Arizona State University School of Earth and Space Exploration. Her name is Melanie Barboni, and let's get her on view here. Let's see if we can get a sort of a view of me and her, and I'll tell everybody why she's important tonight. Hi, Melanie. How are you?
I'm very good, Rick. Yeah.
So we had a bit. I love your eclipses in the background. This is great. So we had a bit of a party last Saturday morning. It was the annular eclipse, and we did something on campus. And then a couple of days later, I just happened to run into Melanie, and she was showing me some images she took, a little kind of a composite image that she put together. And I said, Melanie, do you want to kind of come on the show? And can you help us kind of talk about the moon tonight? And she readily said yes. And so that's why she's here. And actually something more special. The audience is up for a surprise here because it's not just the moon. You discovered something very unique last Saturday, and we want to see it. So Melanie, tell us a little bit more about yourself. What's your research? What do you study?
So, well, hello everyone, and let's celebrate the moon because we all love the moon. So I'm a geochemist, a professor at the School of Earth and Space Scientists, School of Earth and Space Exploration. And actually, I study the moon. I study Apollo sample. I touch them every day. I'm very, very lucky. And I'm looking at the geochemistry and the mineralogy of those rocks to understand the formation and early evolution of the moon and how it correlates with the history of the Earth. So the moon is something very important to me. And obviously, when an event like an eclipse is happening and we can see it in Phoenix, I'm not about to, to miss it. So I'm going to share my screen now.
Okay, thank you. Can I just ask, the rocks that you study, are those ones that the astronauts brought back, or
Yes.
are these meteorites that sort of were lodged off the moon and came visiting the Earth? So
No, those are actually the Apollo sample brought back by the astronaut. I have currently in my safe a sample from 11, 14, 15, and 17.
oh, excellent.
Yeah, and when people visit me and they're actually out because we are studying them, I can actually let them, touch them, which is something very rare. So if you are around ASU and I'm around and the lunar sample are out, we can probably show some of them for you.
That would be great. And we have an event coming up. I'll just say it. You opened the door, but we have an event on November the 4th. It's a Saturday, and it's from 10 to 2. It's a big open house. And so exactly the kind of thing you're talking about happens at that. People get to sort of touch meteorites and sort of like work with clubs and people like that. So anyway, you opened the door. I thought I'd close that. So thank you very much. So yeah, let's kind of see your slides and see what happened. So
So I have a big passion, which is photography. And of course, I take a lot of picture of the moon. So I was excited to go out and take picture of it was a partial eclipse in Phoenix, only like 79%. But the biggest passion I have in my life is actually birding and watching birds. And I also do photography of birds. So I wanted to join that eclipse venture by taking picture of the eclipse. What you don't see if I had another camera with a huge lens for taking picture of wildlife. And I went in the Scottsdale Community College at the north end of it, where there is actually a lot of animals activity, a lot of wildlife present. And I was curious to see how the animals were going to react to a partial eclipse. So that was my setting, that was setting for the eclipse, but I'm also looking at the animals. And Scottsdale is a beautiful place because you can see those little guys. They actually have owl habitat, and there is a lot of burrowing owls in the area.
This one looks like it's posing.
Oh yeah, I mean
Like
they are awesome. So that guy was there looking at me. That was earlier in the morning, so I
Right.
went there just at sunrise, and the owl were still running around. The coyote were out. And by the time the eclipse was about to start, the owls start disappearing in their burrow and the coyotes start disappearing, and all the songbird and all the daybird came out and just started their day. So at that point, I came to actually take picture of the eclipse. There were no more owls, no more coyote around. And I set up and I just made a test shot just before the eclipse started. And I was
We saw those two sunspots here too. That makes sense. So there's one large, one small, and they're going to
enormous. Look
Yeah,
at
and
those.
they're going to disappear during the eclipse, aren't they? They're sort
Yeah,
of like,
they are. Yeah.
Mm.
I was just surprised about how big those sunspots were. But you have to realize the scale of the sun and like the fact that we can see them from here from Earth. They must be really, really big. So that was just a couple of minutes before what I call the moon entry. And at 8:10, that's when it started here in Phoenix. You can just see on the upper corner a tiny little shade, a tiny little dent. That was the moon that was starting to do her show. And then I timed myself and I took picture every 20, 25 minutes. And that's at 8:30, 8:50, and 1 hour after the entry. Like how fast that goes, right? Right here, the moon was already like eaten most of the sun. And of course, Phoenix, we only had 79%. So at totality, that's the maximum that we got at 9:31. Still very impressive. And I will go back at what happened at totality because that was really unreal.
yeah.
But just before I go there, I just want to show you when the moon was exiting. Yeah. And here, the very last bit of the moon just exited the moon, the sun at 11:01. So it was about a 2 hours period. And I really enjoy myself, just like, looking at the moon come and go. But what happened at the time?
Melanie, let me interrupt for just a second. So did you pre-plan to do the 20-minute shots? Did you sort of like figure it out yourself? So I'm going to take, because you got exact symmetry here, right? In the phases moving up to totality and the phases moving out. And you couldn't do that unless you had sort of pre-planned to take these images at the right times, right? So
I knew when the moon was entering, I knew when it was exiting. Yeah. So I timed myself before. And I actually made sure that I had all those shots exactly at the right time. Yeah.
No, it's great. I just love the way this put together. It's wonderful.
Yeah, it was fun to put it on Photoshop as well, because that's when you realize the whole thing, how the moon was moving. So what happened at totality was amazing. So it was not a total eclipse. So it was only a partial, but was the maximum, I should say. But it was that gray light, the shadow where really we're looking, the temperature went down. And not only the temperature went down, but when we reached totality, the owl came out. So that's a picture I took. They were just next to me, next to my camera setting, and they were like asleep in their burrow. But when we reached that, 9:30 time where the moon was shadowing the sun to the maximum, poof, the owl went out and they were looking around, very surprised. And for them, it was like evening. They were starting to run around and beginning their night in a way. And that was really funny because, go ahead, Rick.
No, I just think that is so funny. So clearly, right, you didn't see them, they're sleeping, totality hits, you turn around and there they are, right?
They just came out running of their burrow and they were like, wow, my night was short or my day was short. And that's what was funny because they were really none all at all. And suddenly all the owl came out. And when the eclipse was going, actually, I had a road runner that was just like a little bit in front of me in the grass, and it was trying to sunbath. So at first, at 8, the sunbathing was going pretty well, but the more the eclipse was going, he started like, looking around, and he was not getting as many sun as he wanted. And when not totality, but like the 79%, the maximum actually hit, the coyote went out again. And the coyote, they only go out, when it's like dusk or dawn. During the day, they are not really around. And those guys just came out. That's a picture I took of one at around 9:30 9:30 a.m. And the road runner was not expecting to have coyote again. And, it's not like in the cartoon where the road runner wins. The road runners are actually very afraid of coyote. So that guy was trying to sunbath, and suddenly the coyote went out. And he ran to hide in the tall grass. And honestly, I nearly forgot to like take picture of my sequence, because just watching those critters react to these very unexpected events, the coyote coming out thinking it was dusk, the road runner panicking because he was just going for his day, and suddenly the coyote were coming back, and the owls getting out like it was, evening. It was very, very, very special. And I just thought that you guys might enjoy to share that we are not the only one reacting to solar eclipse.
Exactly. And actually the moon, I think, probably has more impact on us than we know. And we noticed it also. We had a crowd at ASU. We're going to show you a picture in a minute, but we noticed also, I mean, everybody could take a look around. You could see that it's all, the sky's getting tinted. It just, some of the color goes away, shadows get sharper. There's a whole bunch of things that just sort of, I think you can become aware of if you learn how to look for it. But I think there's also this sort of, this in the background sort of a subliminal, awareness of the change and all that's going on. And that's obviously what these animals are feeling too. I heard also that the herds of sheep will sort of like gather together and go hide under a tree during an eclipse, and then come back out and start noshing on grass again after it's over. So there's something going on there, isn't there? Well, how lucky for you to do that. And I missed at the very beginning. I'm sorry, I was looking at something else. But where is this? Is this North Scottsdale? Where is this in
Yeah, I was just at the northern end of the Scottsdale Community College. They have like a baseball field there, and on the other side, they have all these pasture and wildland, and there are tons of animals just in the middle of the city. And it's a very good place to watch coyote, owls, roadrunners, and all these guys. So that's why I pick up that spot to watch the effect on the eclipse on all these guys.
Yeah. I think it's great. Well, great. And we look forward to working with you back on campus. There's always opportunities to sort of like see your research and get that going. And it's such a nice little chance that we sort of like met on Tuesday, and I learned of your amazing composite image of the eclipse here. And I thought that would be worthy for people to see. It sounds excellent. So Melanie, thank you very, very much.
Thank you, everyone. Enjoy the moon.
Yes, and I guess I should say this. I used to do this with the virtual night sky. Is hey everybody, I'm outside, right? And if I look right there, I'm observing the moon. You might be in your living room, but promise me tonight, right? Sometime between now and the end of the evening, you're absolutely going to go outside and really observe the moon instead of just watching us on TV. So we want to do that. I'd like to sort of like invite Kevin O'Connell back to the screen here real quick. He sent me some stuff that he had been working on, and I just was watching this video you put together. And so you'll have to set it up, because all I know is you were in Albuquerque and there's a bunch of balloons. So you set up the situation, and then maybe we can play the video for everybody.
Sure, Rick. Yeah, I actually want to talk about, eclipses in general, because there's so much to look forward to. And even the excitement on the annular eclipse leads into the solar eclipse coming up as well. So we have, lunar eclipses, and people are familiar with them. They happen frequently. Here's a little bit of a time lapse of a lunar eclipse that I shot 2 years ago. So this is 5 hours. Yep.
I love when it turns red, and then it's sort of like a dark shadow, and then suddenly everything kind of goes red. I love that part.
Yeah, and I actually had to do longer exposures, so you can see the stars for just a moment there when it comes by, right? Then there's also Solar eclipses, much more rare and something you definitely want to schedule for. So during the rare total solar eclipse, the moon falls directly between us and the sun, totally covering all of the sun's light, but only in that narrow 50-mile path. So otherwise, it's just a partial eclipse like the annular one was. So it's very important if you want to see the solar eclipse that you get into the path of totality. So try to do that if you can next April. 99% is not the same. I'll just say that right now. Here's my experience in Casper of that total solar
Right, I remember.
eclipse. Yep. So just a little bit of it's about 2.5 minutes and I cut it down to about 15 seconds here. And this is how dark it was. So earlier, Melanie was talking about the darkness. This is what to expect from a solar eclipse. It's like the sunset in the middle of the day, but you can't see where the sun set on the horizon. So it's like dusk all around you. It's just an amazing experience, something I highly recommend. So this is a little bit of some of my footage from the Ring of Fire that Rick was talking about. So I drove to Albuquerque. That was in the path of annularity. What that means is that you could never look at it with your naked eye. You always had to use your glasses. But the moon did align perfectly. And so I have a video, and this is a little different than the one with the balloons. I wanted to focus just on the one about the eclipse. So I'll just show you that it's a good idea to go to like Google Maps like I did first and get a sense of where I was going to park and set up. And I found this location that I liked, and I set up my 2 cameras here. And at about 8:30 in the morning, local time, Mountain Standard Time, the sun came up over those mountains. And then shortly after, the beginning of the annular eclipse happened. So you can see a little chip out of the sun there. And this is now during totality. So annularity, I'll say. It's not totality.
Yeah.
But there's the 300mm lens, and then there's the 600mm lens. And here's the time lapses. So with the 300mm, I was shooting a picture every 10 seconds of the annularity. It goes by pretty fast, unfortunately. But here's the longer shot. So this is with the 600mm lens. And you can see as annularity begins, this is actually sped up 2000%. This would take over 5 minutes if we wanted to sit here and watch it. But there's the moment. At 10:37 a.m. Mountain Standard Time is when annularity took place. So something else fun.
That is beautiful. That was absolutely stunning.
Yeah, so also you've probably seen a lot of these eclipse shadows. We brought a colander with us. We could take some pictures of the eclipse shadows. And believe it or not, a Cheez-It will make a eclipse shadow here. So that's a Cheez-It as well. So, I mean, I did want to say a couple of things about what to do if you're interested in this stuff. Definitely get yourself like an optical lens to protect your camera equipment and your eye, but I don't recommend ever looking through the lens, always just looking at the viewfinder. And this is the screen that I would see. So this is with a sun filter on there. I call it WYSIWYG. It's what you see is what you get. I have a more advanced piece of equipment for capturing the chromosphere and for prominences, and you'll get this kind of a look, but it takes a little more processing for that. So I always say, don't let your technology get in the way when you're trying to enjoy the eclipse. Just make sure you have something you're really familiar with that you can quickly adjust. But again, back to Rick's point, go out and view the moon tonight. This is my 46%-ish, which is what we have outside tonight.
That's about like what we're seeing tonight, isn't it?
Exactly.
So, Kevin, you're always amazing. Oh yeah, play the video. Can we see that?
Well, I have that video. I could play the longer one. You guys want to hear that one with sound and all that?
So how long is it?
It's only a minute and a half, but
Yeah, let's do it. I thought it was amazing. Let's do it.
Let me turn on, make sure I have sound on because it does have a little bit of music. It was, interestingly enough, during the annual balloon festival. So like, what are the chances of that, right? So here's that video that he was describing.
Beautiful.
Kevin, you're a talented man. I loved how you captured the moment and the flavor of the thing. So that's super cool. And are you going to be in, where are you going to go in April for the eclipse, April 8th?
Yeah, I mean, I'm crossing my fingers because when you go online, you look at path of totality, you kind of have to choose places that would be free of clouds, and they tell you percentages if you go to timeanddate.com on the weather and so on. I'm planning to be in Dallas, Texas. So Dallas is one of those unique places that had both in the crosshairs, the annular eclipse and the solar eclipse coming up in April.
Excellent. Okay. We got something to look forward to next year. Excellent. Hey, thank you very, very much. I wanted to introduce my colleague and friend, co-worker for, I don't know, Meg, has it been like 15 years or something like that? But you've got just a couple of shots of some of our festivities last weekend as well, right?
Well, hi, Rick. I just want to give a shout out to all of our frequent flyers from the Marston Virtual Night Sky program. And we see them from the state of Arizona and from outside of our country. We're really wonderful to see all these familiar names, and we're just so glad to have the fans with us. And what I have is a short PowerPoint to share, which I am going to do. And while things were happening at the annular eclipse, we were busy at ISTB4 and at the School of Earth and Space Exploration. And I want to share my screen. One moment. It's been a while, so just trying to
I know
how to do that.
Steve, we're going to have to.
Okay. So here's what was happening inside ISTB4.
Hang on a second. What we have is your Zoom.
Hang on. Oh, sorry. Wait, it's been a while. Wait a minute. Stop share, Meg. Stop that. Okay, sorry. We were busy inside and outside of ISTB4 and just trying to get to that screen. One moment. Sorry for the clumsy. Here we go. And here we go. How does that look?
That's better.
Got it? Okay, so here we see the Earth and the Moon and the Sun, and we're grateful to Sarah and Ralph and Naomi. Sarah is the Earth, Ralph is the Moon, and Naomi is the Sun. And we were very busy in ISTB4. And hang on a minute, I'm trying to move my screen. Just a minute. It's not working for me. Sorry. Here we go. Inside also ISTB4 in the first floor of our Gallery of Scientific Exploration. I want to give a shout out to our friends at the Lunar Reconnaissance Orbiter Camera because they showed up. They had a beautiful display on the inside. Meanwhile, in the Marston Theater, we were live streaming from actually Roswell, New Mexico. Our NASA Eclipse team launched a balloon, and here you see the inside. Here's our friend Rick Alling announcing to us inside the theater. And this is live feed as we're watching NASA live feed. And also this is the balloon with the payload and all of the different instruments. And that followed up into the path of annularity. And then they had to chase that balloon to get the data. And I don't know, Rick, if you have anything to add to that. It was a big adventure for the group.
They ended up having to chase that balloon all the way to Texas, if I remember.
Oh my God, the things we do for science.
Yeah.
Okay, meanwhile, also in the lobby, at one point, we had a troupe of ASU dancers who did a beautiful interpretive dance on our magic planet. We had the sun, and they did a beautiful interpretive dance of what the eclipse does. The young lady in the blue shirt was the Earth, and then all of the friends around. And at the end, which I did not get, they all put on eclipse glasses. And you can see we had a nice crowd inside the Gallery of Scientific Exploration. But if we move outside, also we had some ASU Space at ASU ambassadors and ASU NASA Space Grant, and they were wearing proper eye protection. Outside of ISTB4, we had a wonderful crowd of people that were all properly attired with their ISO registered glasses. And I want to give a shout out to ASU NASA Space Grant intern Ethan Johnson for taking these beautiful shots for us. Now, we had a really good crowd. The ASU Astronomy Club had some telescopes set up. We had two-legged and four-legged people enjoying the eclipse. And these are just a couple of different exposures from the outside. A wonderful crowd. I think we numbered almost close to 500 people came over the course.
Yep, I think that's what it was.
Our lines crossed all across the building. I was there.
Oh, yeah, it was very wonderful. Please note in this image the cool shadows. The shadows of the trees also showed the eclipse. And so a wonderful time was had by all, and we were very glad to be there. And once again, I want to say that I'm just so glad to be back with our crowd, both virtually and together tonight. So I'm handing it back to you, Rick, with great thanks to all who joined us this evening.
Great. Thanks, Meg. Those are great pictures. I love those. I love the sort of the crowd shots, especially. So good. Well, that's what we do. We look at these, we look for these opportunities, and when the phenomenon happens, we're there to kind of help interpret it and give people a good experience. So, hey, I'd like to see if Sam Campbell is available. Is she back? And can we get them? Let's see. There, I see Nick. Yay. Hi, Nick.
Welcome back to the LROC SOC.
Yeah.
It's been a great event out here so far. We've got a lot of people coming through. It's been kind of a crazy day. Started out 2 hours out in the desert doing a local rocketry event. Where sometimes we even work with ASU students as they're getting their high power certs. So we work for space when they're fun time, and we work for space here for our work time.
Good.
We've got lots of people out here at the telescopes, and I think Sam's going to take you on a tour.
Yeah, I'd love, Sam, can you take us outside? I just want to see if there's people out there having fun looking at the moon. So this is
we've had a pretty good spread of people coming through. I think you sort of caught us at a dead moment, but I do have someone that I think would be great to talk to before we head on outside.
Absolutely.
You would like to come over here for a moment?
Great. And Sam, introduce yourself real quick.
Yeah, hi, my name is Sam. I'm a student here at ASU. I am studying astrobiology, and I'm here at LROC to help out with International Observe the Moon Night. And
you've got the best shirt I've seen all night. That's really good.
I do have the best shirt on it, yes.
Okay.
But I want to talk to some young folks who've shown up tonight. Will you give them your name and how old you are?
I'm Shreyan and I'm 9 years old.
And I have a very important question for you. Why do you think it's important for us to study the moon? Do you think
it's important to study the moon because it's a
Do you think it helps us at all learn about what happens on Earth, or?
It's a very sophisticated piece of information about Earth's history, and yeah, a lot of stuff that happened on Earth, a sophisticated piece of Earth's history.
I think
so, tonight is International Observe the Moon Night. So how does it feel knowing that the entire world is watching the moon today? It feels pretty cool. Well, I'm glad you came out today. And do you have any message for any of the kids that are out there looking at the moon today? No, nothing? Well, I'm pretty excited. Thank you so much for stopping to talk with us. Did you go see the telescopes outside? Yeah, we got to see the moon. Awesome. Well, Rick, we're going to head on outside really quick and take a look at the telescopes.
I'd like to see what's going on out there.
Yeah, and see if we're lucky enough to catch the astronomy club members for a quick interview. Let's see. All right. Yeah, we have a pretty good stream of people coming in and out, but it's been a pretty slow at the moment, which is perfect because it gives us the opportunity to talk to Evram.
Hey, Evram, how are you?
Hi. Evram.
The host would like me to unmute.
No, you can leave it there because we'll get feedback.
Perfect.
But Evram, you're a student here at ASU.
Yeah.
What do you do?
I am a undergraduate here. I study physics with minors in astronomy and math. I'm also the president of the astronomy club. That's what I'm doing here tonight. I'm setting up telescopes for this wonderful event. And, we're just kind of hanging out looking at the moon right now.
And you are the president of the astronomy club?
I am, yes.
And why is that a club that attracted you?
Well, astronomy has always been something that I've been interested in, and that's true for a lot of people. But specifically, as a scientist working in like physics and astronomy, I thought it would be really good to kind of get the amateur side of it as well. And when I joined the club, I realized like, hey, I could actually, take up a leadership position here and, help the club grow and develop. And eventually I became president. So that's what we're doing now.
So it kind of fell to you after a wonderful journey.
Oh, yeah, absolutely.
Yeah. And We're out here, of course, looking at the moon. I'm going
We
to
are.
ask you the same question that our brilliant friend earlier answered. Why do you think it's important for us to study the moon?
Oh, so many reasons. You know, beyond just learning about the history of the solar system and the Earth, and of course the moon itself, I think on an amateur level, at least, it really helps me appreciate, like culture. The moon is a fixture that people have been looking at for hundreds and hundreds, maybe like thousands of years. It's, something that everybody knows is out there, something that everybody's looking at, usually at the same time in, some local area. So it really helps me, connect with both ancient people and people today. And I also know that, of course, the moon's not really going anywhere that fast. So people in the future are going to be looking at roughly the same thing. So it's kind of something that unifies the entire human experience, I think.
That's
That's
amazing.
wonderful, Evra. We have one last person we'd like to speak with if we got some time, Rick.
Yep.
Yep.
Yep,
All
just a minute or two, then we're going to go back to, I'll tee up
Perfect.
I'll move out of the way.
Fountain Hills. We're going to
Wonderful.
move back to Fountain Hills after this. Hey,
Oh,
Cole,
well,
how are
we have
ya?
another ASU student here. Would you like to introduce yourself and tell everybody what you do?
Hi, my name's Chloe. I'm an ASU undergrad. I study astrophysics, and I'm a part of the astronomy club.
Why is the astronomy club something that called to you?
My friends are in it, so it kind of came about as I kept getting requested to show up, and eventually I did. And now I coordinate events for the club, and I organize things like this where we come up out and set up telescopes for people.
So the astronomy club really was able to get their claws in you and make you stay.
Yeah.
So same question I asked Evra. Why do you think it's important for us to study the moon? What are we getting out of this kind of stuff like we're doing tonight?
I think it's important to study the moon because through studying the moon, we learn a lot of things about the Earth, such as using stuff to date back how old the Earth could be and how old the solar system is. We did that with meteorite samples and moon rock samples. And from doing that, we can kind of date approximately when events have occurred and stuff like that. And that's super interesting. Studying objects like this as well are more of a transferable skill because other planets have moons, and you can use kind of what we learn about our moon and apply that to other objects.
Yeah. All right, Rick. So you heard it here
Thank you.
with the
see you,
amazing
Chloe.
telescopes
Good
that
you're
we
doing
have
it.
set up. And we are very excited to be out here looking at the moon here at ASU. And it's been wonderful seeing all the things that are going on all around the country, all around the world. And so everybody, when you're looking up at the moon tonight, know that it's the same moon that everybody is looking at, and that brings us together.
That's exactly right. That's
All
why
right.
it's an international
Back to
Moon
you,
Night.
Rick.
Hey, thank you, Sam. Thanks so much. Hey, I wanted to see if we can get Vicky again. Are you, is she there? Is she close? I wanted to see if she can come back on for a moment.
I'm here, Rick.
Hey, Vicky, how are you? Okay, how many people are there? Are they still wandering around a little bit?
People are coming and going, and yes, we got quite a few people lined up at some telescopes here.
Good, good. Can you show us the view of that? I'd love to see what's going on.
Yeah, I have to take a little light with me, so hopefully.
Okay, that's all right.
Everyone say hello.
Oh my gosh.
This is Tony. Tony
Hi,
is one
Tony.
of what we call our star dudes. He's one of our telescope operators. And we've got a line of people here. Hello, everybody.
We're gonna look at Jupiter.
Welcome to Fountain Hills.
Oh, that's right. You guys are probably doing Jupiter tonight too, aren't you? Yeah.
Yeah, we've got Jupiter and Saturn out here. So we've got one telescope that's doing that right now.
Excellent. Well, very, very good. All right. So yeah. So you did. Do you think you had a good turnout?
We did, and the people are really excited. I just did a little bit of a laser tour, and so people really enjoyed that.
Okay.
And let's see here. We've got a couple of other people. Here we've got Scott Adams.
Hi,
Scott
Scott. How
Adams
you
is
doing?
one of our star dudes.
Yep.
That's
great.
And let's see here. Who we got here? Everyone, we're on a live stream with ASU. Say hello.
So Vicky, while you have this group together, I want to ask them something. Okay.
Yes.
All right. You guys have to complete this sentence for me. Are you ready?
Okay. Go for it.
Hey, diddle diddle, the cat in the fiddle. What happened?
The cow jumped over the moon.
You did it. Yay.
That was hard.
That wasn't hard, was it? So good. So are you guys enjoying yourself?
Oh, yeah. Absolutely.
Did you look through telescopes? Did you see some craters on the moon and stuff like that? Did you get a good look?
Tons of it.
Yes, we did.
We just visited Andromeda.
Andromeda.
Oh my
yeah.
gosh. Oh, you're kind of covering the sky. Excellent. Well, good for you guys.
We have so many telescopes here that it's a shame to not take.
Oh,
a
yeah,
look.
that's exactly right. Just point him, give
And
him
here's
a,
our telescope operator. He was showing us a really cool feature on the moon a little bit ago. Tell us a little bit about that. What was that shadow you were showing us in the crater?
We're looking at sunrise on the moon. We were looking at a crater wall that was shadowing quite a large part of the crater.
yeah.
So it's
Okay.
a very large chunk, and you can actually see some real good detail.
That's great. Anything in the bottom of the crater? Sort of, I guess you see a little combination of the ones that have the internal sort of high.
We saw actually one of the customers pointed out. She goes, "Oh, there's a mountain in the center of that crater." And I told her how that happened.
Good. Yeah, it
The
happens.
impact rebound.
It happens a lot, and we see, and that's really great. So, what size telescope are you using?
I've got my 10-inch out tonight.
Okay, that sounds about right. And what they're using at campus, so we were just visiting them, I think are 11-inchers. So like those are nice scopes that give you a lot of detail of those craters.
This is a nice Dobsonian. So they're perfect for nights like this.
Oh yeah, that'd be good tonight too. Oh, that's good. Well, good for you guys, and have a great rest of your night. It's a beautiful night. It's probably about 6 degrees cooler there than it is here, I would guess. Vicky, is that right?
Yeah, usually is. So come on out to Fountain Hills anytime, Rick.
All right. And so people can kind of keep an eye, look at your website. So what keywords are we going to look at if we're going to find your website and find events?
Yeah, they can just go to fhdarksky.com.
Okay.
And we've got a lot of events coming up here. We do stargazing hikes out here. There's all kinds of fun stuff we do. One thing you made mention of when we were chatting earlier that I forgot to say anything about. You had asked about the Smithsonian, our relationship with the Smithsonian.
Yeah. So I heard an announcement. So you've made some sort of an agreement with Smithsonian. What's the deal?
Well, it wasn't an agreement. Smithsonian has opened a new exhibit called Lights Out. Okay. And it's all about protecting the dark skies and the impact that unnecessary artificial light at night has on humans and wildlife and, our ability to see the night sky. And so they have this amazing new exhibit, and they chose just a handful of international dark sky places to feature, and Fountain Hills made it into the Smithsonian.
Excellent. So I think that's great. And so I know you guys are so energetic and so enthusiastic about your projects, and it's so professionally handled. I just think there's no end to what you can accomplish out there. I just know you got the right people in the right moment to do it. So this is great.
Well, thank you. We're pretty excited about what's happening and the enthusiasm we see in the community too.
No, great. Good. Well, you've got lots of friends out there, and keep them looking up, okay?
Yeah.
It's your job to keep them looking at the sky.
Absolutely.
Okay. Hey, Vicky, great to work with you guys, and we'll see you, we'll chat with you next week about sort of some wrap up, okay?
Awesome. Thanks, Rick, for inviting us.
Okay, bye-bye.
Bye.
That's great. Thank you. So we wanted to kind of just do real quick. I want to go back to LROC. We've got a little bit of time, and we were, and Nick, you'll have to remind me. I think it was Tori that was going to do a little geology for us on the moon.
You're looking for the geology tour? Is that what you said, Rick?
Yeah. Yeah, that's right, Sam. Or we can go someplace else and just come back real quick if you want.
Hey, Rick. I'm ready to give a little tour of the features that we can see tonight on the moon.
That would be great. So if you don't mind, let me get you live here so I can see who we're talking to. Oh, there you are. Hi, how you doing? So we sort of assigned a little bit more time, but we're kind of running short. So if you don't mind, can you just give us about 3 or 4 minutes of geology?
I'll do my best. Yeah.
Please introduce yourself, Madeline. Please introduce
it's a huge
yourself.
Subject, and it's like, what do you guys do? And you got 3 minutes to tell me.
3 minutes of geology.
Can you?
No, of course. Yeah.
Please introduce yourself and what you do.
Yeah, so I'm Madeline Mannheim. I'm with the LROC team here at ASU. Hopefully you can see my screen here. I make what we call digital terrain models, so 3D models of features on the lunar surface, and we make those to help scientists understand geology and also to support exploration. So you can land in a safe space, drive your rover in a safe area, that kind of thing. But tonight, I'll just talk about what you can see if you're out observing tonight. So just real quick, this is what the full moon looks like to orient ourselves. And of course, tonight we're seeing a waxing quarter moon. As you've heard already, the terminator is this line between the illuminated half of the moon, east half of the moon, and the shadowed half that we can't see. So real quick, why are we having Observe the Moon Night on quarter moon? Well, partially it's logistical. On a full moon night, the moon will be at its highest point at midnight, which isn't so great for us. Whereas a quarter moon is going to be directly overhead when the sun is kind of on the horizon at sunset, which gives us a nice time frame to observe. All right, and then another reason is that when we have the sun from the side, as we do in a quarter moon, we get these dramatic shadows near the terminator. And that lets us look at these topographic features in this, kind of dramatic relief. So that can be really cool. All right, so the first thing we see are these kind of these dark patches on the moon that give us that classic man in the moon. These are called mare, which ancient astronomers thought maybe were bodies of water. Mare means sea in Latin. We know now that what they are is volcanic lava, so they're basalt rock. And that basalt is really iron rich, and that's what gives it that dark color. The lighter areas, which we call the highlands, are made of anorthosite. And that anorthosite is almost as old as the solar system, so older than the mare. These are called, these also have Latin names. Serenitatis, Tranquillitatis, and Fecunditatis are the three main ones that you can keep an eye out for. And that you may be able to see with your naked eye even. Tranquillitatis is the one that people maybe know best, just because the Apollo 11 landing site is in that mare. Chrysium is the Sea of Chryses, and Mare Nectaris is the Sea of Nectar. Moving on to a slightly smaller feature that you can look out for, especially if you're observing through binoculars or a telescope. We have these two really dramatic mountain ranges, which kind of separate and define the boundaries of Mare Serenitatis and a mare that we can just barely see the edge of, Mare Imbrium, or the Sea of Showers or Rain. So at the bottom, this is Montes Apenninus, and then at the top, Montes Caucasus. And so these peaks at their highest are 3 to 4 miles tall. Apenninus continues here, but it's a little bit lost to shadow. But because they're so close to the terminator, they should be pretty dramatic tonight. So that's a good feature to look out for. And then if you follow that a bit north, we have these two craters here, which are Aristoteles, named after Aristotle, and Eudoxus. So Aristoteles is about 55 miles across. So you could pretty easily fit the city of Phoenix within the walls of that crater. And then just going off to the east a little bit, this one's going to be hard to see tonight unless you've got a pretty good telescope, but it's one of my favorites, so I thought I'd point it out. We have this prominent crater here, which is called Berg, that's in a splotch of this darker mare basalt. And that mare, or that kind of area, is called Lacus Mortis, or the Lake of Death. So that's a good one if you can find it to point out to your friends. And then real quick, just last thing, these three craters, they're a little bit further away from the terminator tonight, so they may be a little bit harder to see, but they have a pretty distinctive shape. The top one is called Theophilus, and it has a central peak. That's like a mountain in the center of this crater that was formed at the same time that the impact crater formed. And that central peak is about 1.5 miles tall in that crater floor. So if you can see the central peak of Theophilus, you've got pretty good eyes, or a pretty good telescope.
It's a good telescope, I think. I'm not sure you can see that with the naked eye.
Yeah, probably not. Good eyes and good binoculars is, I think, good
These are
photo.
beautiful images. And you really have a command of those names. You've got really good pronunciation. So
Yeah, there's some tongue twisters there.
there are. There are. So
Um,
can I just ask, so I'm just observing, I'm looking, right? I look at the moon right now. So I can distinctly see serenity, tranquility, and fertility
mhm.
so, and I think I can I can see nectar a little bit, Mar nectaris a little bit. And so, but are there any like just like big craters or anything like that you can see? I'm sort of seeing the dark patches that are seas, but with the unaided eye, what is there? So there's some other stuff.
With the unaided eye, you may start to be able to see some of the craters right along the terminator, although I'm not sure if you could, really separate them out with your naked eye.
I see.
Aside from the ones I pointed out, I think the one larger crater is Posidonius right here on the edge of Mare Serenitatis, which is named after Poseidon. But that one I think is a little bit small as well. I think the Mare are really the best thing to look for with the naked eye. And then here I'm actually just showing, so far what I've been showing are renderings. They're renderings that use LROC images. These are photos, and I just wanted to show that, depending on what you're looking through, you may see the moon through your telescope as flipped or upside down or rotated or both or all of those. But because, these features are mostly near the terminator, your major mare, hopefully you can kind of orient yourself and start seeing some of these features.
I think so. It makes sense. Can I ask you a big question about Montes Apenninus?
Apenninus, I think.
Apenninus.
What I've been saying.
Was that one of the Apollo missions? Didn't it sort of land in that particular area? Is that right?
Yes, that's exactly right. It landed
It looked familiar to me.
Mare Imbrium, yep. So the Apollo 15 landing site is right around here somewhere, if you can see my mouse, right at the base of those mountains, like on the terminator tonight.
Excellent.
Yeah.
And then you said north of site is ancient. And so if I remember my moon history, really the surface that we get to see is really very, very old, right? Isn't it like 2 billion years old, not changing very much? Is that right?
Yeah. So the Mare are 2 to 3.8 billion years old.
Okay.
And this Northosite is, very old, 4.4 billion years old. Because the moon really doesn't have an atmosphere. There's no wind. There's not a lot to degrade the surface in terms of in that respect. But at the same time, there's no atmosphere to protect from like little impacts on the moon. So yeah.
I just wanted to sort of like introduce another element to the show here real quick. Madeline, I'm not sure if you've ever met my dog, Luna.
I don't think I have.
Luna just got a dog treat, so she's like, I'm trying to kind of like keep her focused. So maybe she'll be back in just a minute. Then one more quick question, and that is that when we look at other surfaces of other things and things like that, we use cratering as, and the amount of cratering and the distribution of cratering to kind of talk about the age of the surface of objects. Is there a simple explanation for that? Thank you.
Yeah, so one way that we can age things on the moon. So when you think about ages, you can figure out how old things are relative to each other. So what's older, what's younger, or you can come up with an absolute age. So for absolute age dating, you want samples. So we for the moon, we have these Apollo samples, so they can do some absolute age dating. But one thing, a way to start looking at relative ages is just look at what is on top of, something else. So for Theophilus and Cyrillus here, we can be pretty sure that Cyrillus is older than Theophilus just because Theophilus has kind of imprinted on top of that rim. So that's a great way to do it. We can also
put together a cratering history, what came first and what came next.
Exactly. Yeah.
And then I'm assuming then the basaltic material sort of then drifted up and spread out across the surface after essentially the sort of surface was formed, I'm guessing, right?
Yeah, there was kind of an episode where they were formed. My lunar volcanic history is a little spotty, but
I'm doing it from memory too. So.
Yeah.
Madeline, yeah. Well, thank you very, very much. I'm sorry, we're sort of like running a little bit behind, but I wanted to do this and actually just sort of encourage people, right? When you're looking at the moon, you're looking at something substantial, and you're looking at geology, and you're looking at processes. And I think people kind of generally look at the moon and say there's dark splotches and there's light splotches, but I don't think a lot of people know that this is two different kinds of material, and they kind of formed on the moon in different ways at different rates. And that's all kind of important to the moon story. Is that right?
Yeah, exactly. And rocks that are, very, very similar to what we have on Earth, basalt and anorthosite, which, we essentially have here.
That's it. I remember, I'm old enough to remember when Apollo missions went, and we didn't know what we were going to find, and we brought all those rocks back. And of course, what we discovered is that all of the minerals and everything and the compounds and everything is stuff that we also find on Earth. So no big surprises there, but we had to go check it out, right? So
exactly. Yeah.
Then we'll go again. Madeline, thank you very, very much. And would you extend my big thanks to everybody at Lunar Reconnaissance Orbiter Camera, the center on the ASU campus, and for their help tonight and all of that stuff. And so I'm going to kind of move on to the next segment of our program. But thank you very, very much for putting that together. It was very informative, and I think we got a little sense of lunar geology, what we're looking at. Thank you, Madeline. All right, so next thing I kind of wanted to do is I wanted to invite Alex to the screen. And Alex is sort of, one of the things we were talking about is sort of the cultural history of the moon and the cultural significance of the moon. And I think people sort of that watch the news and sort of see things happening, they're hearing all kinds of different things about blood moons and new moons and blue moons and this moons and those moons. Can you kind of pull that apart for us a little bit and say, what do all those things mean? And why do we have so many names for the moon anyway?
Yes, absolutely I can. So yeah, there are a lot of different moon names, and some of them are misleading and very misleading, in fact. So I got a bunch of moons, and I have a presentation to go over all the different moon names that you might be hearing throughout the year and what they mean. So it's a bird, it's a plane, it's a supermoon, moon names and their meaning. So the thing is, a lot of moon names simply come from when they happen during the year. A lot of them happen during full moons. Full moons are markers. We usually have at least 12 in a year, so they line up with months. And a lot of different cultures around the world have come up with different names that these moons relate to and what they might signify. So for example, a lot of these common ones here in North America, January is the wolf moon. This references when moons are out during the winter time and kind of traveling in their packs. February, snow moon, it's still snowing during February. March as the worm moon, that one's interesting. It's because when earthworms start to come out of the ground during the summer thaw or the spring thaw, and so you get worms all over the ground. This actually comes from a lot of the native tribes that were first here in the Americas that called this the worm moon. The pink moon, this actually specifically refers to phlox wildflower. These bloom pretty early in April. Whereas May, the flower moon, is when all the rest of them do. And then June is when strawberries start ripening, so it's the strawberry moon. The rest of the year, buck moon, this is when buck deer start growing their antlers. August sees a lot of sturgeon in the Great Lakes and surrounding areas, so we called it the sturgeon moon. September is a great time to harvest corn, where it is, so corn moon makes sense. And then October and November, it's when everyone starts to prepare for winter, whether you be a hunter or a beaver. So October is the hunter moon and November is the beaver moon. And then I feel like the December being the cold moon is pretty evident. It gets cold. So there are a lot of different names for moons across a lot of different cultures and across a lot of history. And that's because they've been used to identify times in seasons, whether it be harvesting or hunting, or just in how nature changed around us. So those full moons were used as kind of identifiers. Then there's the other moons, the ones that you hear more often in the news. This includes like the harvest moon. The harvest moon is something that used to be very important, probably not so much anymore unless you're very classically agrarian. But this is the full moon that happens closest to the autumnal equinox. This is around September, anywhere between the 21st and the 24th. It's called the harvest moon because this is a very bright moon that happened during the harvest season that allowed farmers to work late into the night because the moon would be so bright that you could still work under that light. If you've ever gone out during a full moon, you might have noticed that there is even a shadow sometimes. And so that's great for if you're harvesting late, trying to get all those crops in before the winter. Now, this is one I feel like is the most misleading. This is the blue moon. The moon does not actually turn blue. If you've looked at a blue moon, you've noticed it's not blue. This is basically just how, when I talked about there are 12 full moons in a year, well, sometimes there could be a little bit more because our months are 30 or 31 days. The lunar cycle is 28. So we usually have one per month, but we can occasionally get a second, and that's always called a blue moon. So a second full moon in any month is always a blue moon, although not actually blue.
But it's
now
not
the blood moon.
It's not really that blue, is it?
No, it's not really that blue. That is a very edited picture for the sake of also misleading, apparently. I don't know why everyone wants to make the blue moon really seem blue. Now, the blood moon, on the other hand, is an actual color shift. It's called a blood moon. The more scientific term is a lunar eclipse. This was what happens when the moon falls behind the Earth's shadow. You can see the diagram at the bottom there. And then all the dust and chemicals and gases in our atmosphere change that sunlight's color so that it's a deep red or orange, depending on who you might ask. So these are blood moons. Much rare. You have to have a total lunar eclipse to be able to see these. You have to be in the path where it happens. But once you do, it's a nice dark, dim red. So that is a blood moon. Then we have something that a lot of people, I feel like attribute a great deal to. These are supermoons and mini moons. Like all other orbits, the moon's is not perfectly circular. It is elliptical. So there is a point when it's closer to Earth than on average and when it's farther away. This is our supermoon and our mini moon. So when a full moon is near the closest point in the moon's orbit, we call it a supermoon. It's about 20,000 miles or 10,000 miles closer than on average. Now, if it's at its farthest point in a full moon, we call this a mini moon. Between the two, there's almost a 30% difference in area when we see it in the night sky. So you can actually see this picture taken by a National Geographic photographer actually shows the difference in size between a mini moon on the bottom and a supermoon on top. So there is a noticeable difference if you're looking at them. Now, an average moon, you might not be able to see the difference as much, but I promise it's there. But these just tell us that the moon's a little bit closer or a little bit farther than what we're used to when we see it in a full phase. So these are all the different moons you might hear. All of them are usually full moons. So if you're ever looking for the different moon names and trying to figure out what it is, don't think a supermoon is going to fly in and save the day. Don't think a blue moon is going to be a nice, jazzy, dark blue. Just keep in mind that these are just ways that we tell what the moon is doing and how it's different.
Alex, thank you. Excellent presentation. I've never heard it so concise and so very well done. Nice graphics. Thank you. Thank you so much.
Thank you.
And good luck with your adventures. So I think I announced before we started, right? Alex is a former student of ours, has done work with us and was part of our virtual programming during COVID. And now he's off in San Diego and he's on to the next thing. So Alex, thanks for joining us tonight. We're gonna wrap it up. We've done a lot about the moon. We started a little bit late because of some tech things. We've gone a little bit long, but I wanted to see, let me see, can we just get Kim and I sort of next to each other on the screen here? Hi, Kim, how are you? And, oops, we need your mic on.
There we go. Sorry.
And so you actually are in the thick of things. You're over at LROC, but you've been kind of working, holding this whole thing together. But
I'm in mission ops with Nick's out in the lobby. So yeah.
So for you, our little conversation, we got 4 things to do. First, I wanted to have you and I both help remember everybody that was on this program and thank them very much. So thank you for the LROC team, so Nick and Madeline especially, and Sam and Evram and Cole that were sort of over there kind of helping us out. Thank you guys from Fountain Hills for joining and getting us an update on that particular thing. Mark Johnson, that was incredible. I'm glad you're out there. I'm glad somebody's out in the middle of the desert looking and imaging Studying the Moon. Kevin O'Connell, you're always amazing. And thank you so much for bringing your insight and your special graphics and talent to the program. Let me see. Meg, thanks for a little thing about the eclipses. That was really super cool. Melanie Barboni, Kim, that's the first time she's been on our program, isn't it?
I think so. Yeah.
She's a keeper. We got to have her back. We got to kind of like do
We
some,
got to come up with a new show.
something with Melanie for sure. And so, so I don't know. Did we miss anybody? Did we got that's pretty much, I think, the big.
You said the astronomy club, so yeah, I think you kind of got everybody. So it was a rough start because I think we're all a little rusty from doing.
We got over it.
It
didn't happen. So before I wanted then second thing before we kind of get to some upcoming events, and then we'll sort of do a wrap here. But can you just tell everybody a little bit about your experience last week? So our school has been really super busy. We've been doing a lot of stuff, and by far the big signature thing was the launch of the Psyche spacecraft.
Psyche mission, yeah, yay!
Kim was there. She got to Florida. She saw it go. So was it?
I was there. I got to go and see it. I don't know if you guys can see my. I don't think it'll show.
We can't. It's not going to show you very well, but
yeah. It was amazing. It was a week of outreach at Kennedy Visitor Center, just talking about all the things that we do here at the School of Earth and Space Exploration. And then got to go to launch and see the actual launch. So it was an amazing experience. And I'm thinking it's like 12 years in the making to get to last. I encourage everybody to go see a launch if they can. That's like a bucket list item. But I was fortunate enough to be there with my counterparts from NASA headquarters and JPL and the DSOC folks that are helping with the communication part. And yeah, it was an amazing experience. Jim Bell killed it on the NASA show. And yeah, so it was just, it was great to be able to go and represent ASU for that. So
and this one was a Falcon Heavy, so they don't get much bigger than that. So did it make a noise? Sort of...
two sonic booms when the boosters came back. We couldn't see it because the weather was cloudy and overcast, but you could hear it. So yeah, it was amazing. It sounded different from the one that I was with Craig Hardgrove last year. So, but yeah, amazing experience.
Are you catching up on your sleep? Are you sort of getting back to normal?
And trying to catch up on all my emails.
and then we threw this in for you. So, but thank you so much for helping out tonight. I really appreciate that. But can we just tell people real quick, we got some things coming up, right? So
two events. So next Saturday we have homecoming from 1 to 5. We'll be located on University Avenue. So we'll be there for 4 hours before kickoff. Kickoff's at 5 p.m. So we'll be there starting at 1. So stop by and say hello. And Rick, you're hosting a public program that day, I believe.
We are. We're talking about our solar system, all pieces and parts of it. And then we're highlighting about 5 missions, including the Psyche mission that is also exploring that solar system. So so that's available at 1 o'clock on that Saturday. So you can do the show and go to the football game.
And go to the game.
And go to the festivities. So that's
and then the following week on November 4th from 10 to 2, we'll be hosting Earth and Space Exploration Day at ISTB4. So another opportunity to come and meet all the amazing people that are doing fantastic work for the School of Earth and Space Exploration. Rick will also be providing some 3D programming for us. So it's a good opportunity just to come down and see what we're doing and learn more about it. So yeah, 10 to 2, November 4th. That's the place.
All right, super cool. So thank you everybody that joined us tonight. I really appreciate your interest in our programs. I hope we kind of delivered you a whole bunch of different things to think about the moon. But the most important part of the program and what I think is that there's ways we sort of can experience the night sky, but we have to take advantage of it. And so if this is that one day of the year, we just say, hey, stop for a moment, stop and look, stop and take notice. Look up there. There's a moon and it's got all kinds of history. It's got all kinds of background. There's new science happening on the moon every day, and you can sort of enjoy it on all kinds of different levels. And so so that's really what we do. And so I just really encourage people to get outside, keep looking up, keep looking at phenomenon, and keep learning about sort of the natural history of these things and how they work and why they are what they are. It's fascinating. It's part of our world and part of our universe. And sometimes I think we move so fast, we forget to stop and take a look. So if there's nothing else I can sort of add to that, International Observe the Moon Night is really just about taking a moment and sort of understanding our cosmology and our place in the universe. And so I appreciate everybody for joining us tonight, and look forward to seeing other programs that we put together. And I'm going to go ahead and call it quits and say goodnight, and invite everybody to just go outside and take a look at the moon. I'm looking at it right now. It's still there. It's right where it belongs. So thank you, everybody. See you soon.